Namaskar. We will start the presentation of pulse modulation techniques. Various pulse modulation techniques are available. So far we have studied continuous wave modulation, in which amplitude modulation and angle modulation we have studied in the last year analog communication. Now in this course, which is digital communication, again digital communication is basically based on pulse modulation. So pulse modulation is in turn divided into two categories. One is analog modulation and the other is digital modulation. So this analog modulation is bit different from the analog modulation of continuous wave modulation. The basic difference in continuous wave modulation and pulse modulation is that here the carrier signal is not a continuous wave signal, but it is a pulse. That is the basic difference. And there are certain properties of pulses. Say for example its frequency, its amplitude, its position, the width of the pulse. So amongst these parameters, one parameter will be changed according to instantaneous amplitude of the information signal. So basic concept is same. The difference is the carrier signal and the parameter of the carrier signal which is changed according to instantaneous amplitude of the modulating signal. So analog modulation in turn is categorized as pulse amplitude modulation, pulse width modulation and pulse position modulation. Digital modulation has four types. One is pulse code modulation, which is the base of the digital modulation. From pulse code modulation, differential pulse code modulation, so DPCM is developed. From DPCM, delta modulation is developed, and from delta modulation, adaptive delta modulation is developed. So these are the categories under digital modulation, and PAM, PWM, PPM are the categories under analog modulation. The aim of this presentation is to study analog pulse modulation. This is the introductory diagram of analog pulse modulation. Here the uppermost waveform is the carrier signal, which are the pulses. We call them as pulse train. These pulses have finite width and finite amplitude and finite frequency. Second waveform is the information signal or sinusoidal signal, modulating signal, which is the actual information source, and this signal is superimposed on the pulses now. Pulses are acting as a carrier. In the third waveform, the amplitude of the carrier, it means the amplitude of the pulses are changed according to instantaneous amplitude of the modulating signal. So the third waveform, this waveform, is the PAM output. In the second last waveform, that is this waveform, here the width of the pulses is changed according to instantaneous amplitude of the information signal. So you may see certain pulses are having greater width where the amplitude of the analog signal is greater, and certain pulses are having lesser width where the analog signal or information signal goes less or negative. The last waveform, that is this waveform, is the pulse position modulation, where the pulse width is same but its position is changed. So you can consider this as the phase modulation of the continuous wave modulation. Now one by one we will see these three methods. To start with pulse amplitude modulation, the definition is that pulse amplitude modulation is the process where amplitude of each pulse is controlled by instantaneous amplitude of the modulating signal. Now there are various methods of sampling the analog signal that we have seen in the previous lecture. Those are natural top sampling and flat top sampling, or natural sampling and flat top sampling. So these, if you sample the analog signal using one of these methods, then accordingly pulse amplitude modulation will be categorized. Second categorization or second classification is single polarity PAM or double polarity PAM. Now this waveform is the output waveform of pulse amplitude modulation. The upper waveform is the information signal. Second waveform is the pulse train or carrier, whose one of the parameters is now going to be changed. Which parameter we are changing now? We are changing amplitude. And what is the type of the sampling? It is natural top. You can see that the top of the modulated pulse is not flat, but it is changing according to the shape of the sine wave signal. Second point is that modulated signal has both the polarities. It has positive as well as negative pulses. So this is double polarity natural top PAM. If you want to have single polarity natural top, then simply the DC line will be shifted downward, or the zero line will be shifted downward, and the modulated signal have certain average value. This diagram shows the pulse amplitude modulated signal where we have sampled the analog signal using flat top sampling method. So last waveform is the pulse amplitude modulated signal, where you can see that the top of the each modulated pulse is flat. Secondly, the modulated signal has single polarity. There is no negative pulse. It means there is a average or DC value in this output. So these are the types of PAM. Now how to generate pulse amplitude modulated signal? It's a bit simple. Initially, the modulating signal is made band limited using low pass filter. Band limiting the signal means what? Any high frequency content beyond W Hertz is attenuated, so that the output of the low pass filter will have frequencies from 0 to W Hertz. So this is called as band limiting of the signal. This we have seen in the sampling also. Now this information signal, which is band limited, is multiplied by the pulses. So there is a pulse generator which is generating pulses of time period Ts. It means its frequency is sampling frequency Fs. After multiplication of these two, you will have the output which is shown in the diagram. Now of course we have shown output dual polarity and natural top. You can have different multipliers or some modifications in the multiplier circuit, where you could have the single polarity signal or flat top PAM output. This is the simple circuit. You may conclude that the actual circuit is smaller than the block diagram, and it is the fact that the use of simple field effect transistor will generate PAM. The drain is connected to the pulse train, and actual input or information signal is connected to the gate, and the output is obtained at the source terminal. You can do it using simple breadboard, or you can have a simulation on the Proteus. The demodulation of the PAM signal is shown in here. This is the circuit which is of low pass filter. So simple low pass filter will extract information signal from the PAM signal. Now if you want to consider the advantages of pulse amplitude modulation, then you can see that it is the base of all digital modulation techniques, because in all digital modulation techniques you are going to have a sampling, and this is what is happening here, and sampling is done using multiplier. So that is one of the advantages. Another point is that if you look at the transmitter or say PAM modulator and demodulator circuit, you can see that they are simply made up of very simple components like R and C and field effect transistors. So complexity is not there. So these are the advantages of pulse amplitude modulation. But as this is the pulse modulation, its bandwidth is very high, so this is the disadvantage. Another thing is that Nyquist criteria you have to follow. Another important point is that in PAM the amplitude of the pulses are going to be changed, so power is certainly varying. So for higher modulating signal, higher power will be needed. For lower modulating signal, lower power will be needed. So power goes on varying and higher power also will be required. Another thing is that as the information is stored in the amplitude of the pulses, noise immunity is less. So these are the disadvantages. Irrespective of all these disadvantages, pulse amplitude modulation is used in computer network communication, in the electronic driver for LED blinking, for generating motor control signals and so on. Another classification of the pulse analog modulation is pulse width modulation. It is also called as pulse duration modulation because the duration or width of the pulse is changed. In pulse width modulation or pulse duration modulation, the width of the pulse carrier is varied in accordance with the sample value of the message signal. So according to instantaneous amplitude of the message signal, the width is varied. Now the variation in the pulse width is carried out in three ways. You can keep the leading edge constant and you can vary the pulse width by varying the trailing edge. You can keep the trailing edge constant and you can vary the leading edge, or you can keep the center line of the pulse constant. So three different ways are there. In order to generate the pulse width modulation, you have to use sine wave generator or say information source for the message signal and ramp generator. The ramp generator signals frequency should be much higher, at least 10-20 times than the sine wave generator. And if you apply these two signals to the comparator, now comparator study is going on in your 4th semester LIC course. So you may be knowing comparator. It has inverting and non-inverting input. To these two inputs, you apply message signal to one of the inputs and ramp generator to other. And the comparator output will be nothing but the pulse width modulation output. Very simple. For this, you can use 555 IC. 555 IC has three modes of working. In this diagram, monostable connection is shown. So monostable is the circuit which produces pulse when trigger pulse is applied. So clock input is applied to the trigger, and this pulse will have a constant width if you connect pin number 5 to the ground through capacitor or if you keep it open. But now in order to have PWM output, you are applying information signal or modulation input to the pin number 5. So as modulation input increases, the pulse width of the output increases, and as modulation input amplitude decreases, accordingly the width of the PWM output will be decreasing. So this is simple circuit of the PWM. PWM demodulation is bit complicated if you compare it with the PAM. So this is the drawback. Here the PAM signal is applied to the ramp generator as well as synchronous pulse generator. So ramp is generated, which is added in the synchronous pulse generator. So these two outputs will form simple signal or say analog signal with discrete states in the analog signal. And after passing this signal through the low pass filter, you will have the analog signal or information signal at the output. So this is simple pulse width demodulation. This also you can implement using very simple circuit of 555 or comparator circuits, and you can implement it using breadboard or Proteus simulator. The advantage of PWM pulse width modulation is that again you can have that it is a simple procedure for modulation, bit complicated procedure for demodulation, right? So these are the advantages and disadvantages of pulse width modulation. Another advantage of the pulse width modulation is that the noise immunity is bit higher than the PAM because pulse amplitude is constant, right? So noise immunity is bit higher. The drawback is that as the width is changing, the average power will also be changing. So there is no constant power output if you compare it with the pulse position modulation. The application part of the PWM includes some telecommunication systems to control the amount of power delivered to the load without incurring losses. Audio effect and amplification purpose. PWM signal also is used to control the speed of the robot. It is also used in embedded applications and so on. From the PWM, pulse position modulation is devised or developed. In pulse position modulation, the position of each pulse in a signal is varied according to instantaneous amplitude of the modulating signal. The width of the pulse is changed or varied with some reference. Hence, in order to establish the reference, ppm is generated from the PWM. So sine wave generator, ramp generator and comparator, these blocks are of PWM. To the PWM output, if you connect monostable, or another way, if you connect simple differentiator, then also ppm signal is generated. This is the simple circuit. The left 555 circuit is the PWM and the right hand side 555 circuit is ppm, where the output of the PWM is used to trigger the monostable circuit of the right hand side 555. So the output of the right hand side 555 is the pulse position modulation. The demodulation is again very simple. You have to use PWM demodulator. It means ppm output is initially converted into PWM using RS flip-flop, and then it is applied to the PWM demodulator in order to have the PWM demodulated output or to extract original information signal. The advantages of ppm are again same as PWM. The important point is that the width and the amplitude of the pulse position modulated signal is constant, so constant power will be outputted. This is the very important advantage of ppm. The disadvantage is that it needs extra circuitry compared with the PWM. The application includes radio frequency communication, then contactless smart card, high frequency RFID tags, etc. Now you have studied so far these three methods: pulse amplitude modulation, pulse width modulation and pulse position modulation. So you can easily sweep through the comparison chart of these three methods. The first parameter is for the comparison is varying parameter. Which parameter of the carrier pulse is changed? In PAM it is amplitude, in pulse width modulation it is width, and in PPM it is position. Immunity, in PAM it is less, in PWM it is high, in PPM it is very high. Signal to noise ratio, it is equivalent to immunity only, low, moderate and comparatively high. Synchronization is not needed in the PAM and PWM, but it is needed in the PPM because the phase is coming in the picture in order to store the information. So wherever there is a phase information needed, synchronization is must. Then bandwidth, it is on the pulse width, it is on the rise time of the pulse, and it is on the rise time of the pulse. Pulse bandwidth dependency. Bandwidth requirement in PAM it is less, and in PWM and PPM it is bit high compared with the PAM, right? Then implementation complexity, it is in PAM it is so simple, in PWM it is bit complicated, in PPM it is more complicated. So these are the some comparison points, and finally you can have the waveforms of the comparison. The leftmost waveform is of pulse amplitude modulation, the middle one is of pulse width modulation where the width is varied and the amplitude is constant, and in the rightmost waveform the pulse width and the amplitude is constant but its position is varied, right? So that's all about the pulse modulation techniques. Thank you.